Hi everyone, so today we're going to continue with section 5.6, talking about characteristics of polynomial functions. As we go through the material today, some of this vocabulary might seem familiar. We have used this vocabulary before when we talked about characteristics of absolute value and characteristics of quadratics. So let's go ahead, let's jump right in. So we're going to go ahead and look at this first picture here. This graph is of the function f of x, which I gave you the polynomial up here at the top. And so what you're going to see, I just want to break down how the graphs are going to be. In every graph, you're going to see a point A and a point B. We are going to need to use the coordinates of these points when we are finding things like increasing or decreasing. And we will be providing the coordinates to the points for you in a little box. So right here in this box, I gave you the coordinates of A and of B. It gets a little messy if we write them in. I do recommend, I think it is helpful for you as the student when you're working through the problem. Sometimes it is helpful to write it in yourself just so that you know where everything is. And I'm going to take a minute and I'm going to go ahead and write these coordinates in. So A was negative 2.12, comma 2.03, and then B was 0.79, comma negative 4.10. Okay, so let's go ahead and let's go through some of this vocab. We're going to go a little bit more in depth with this problem and review that vocabulary. So the first thing it's going to ask us to find is domain and range. So domain and range here is how far left and how far right the function reaches on the x-axis. So we're looking for our possible x values. And so what I like to do is hold my pencil vertically and scan from left to right and see what possible x values that I have. And so we're going to go ahead and see if we were to do that. You can hold your pencil up to the screen. You're going to see that to the left we have an arrow, so that means that this graph is going to continue. So I would still have x values. If I were to go ahead and scan my pencil to the right, I'm going to see that I have an arrow going up, so this function would continue to the right to keep going up, and I would have all those x values. So this is going to mean that my domain is going to be negative infinity to infinity. And this will happen with every single function. This happened when we talked about an absolute value, it happened when we talked about a line, it happened when we talked about a quadratic. So I know that every x value is possible. Now my range was a little bit trickier. So with the range, we're going to go ahead and we're looking at the y values for that. And so we can go ahead and we want to look for the lowest y value. So I like to look at the bottom of the graph. And I'm going to see that I have an arrow here. So I'm looking at the y values. So I'm looking at the y-axis. I always think y to the sky. So y is the axis that goes up and down. And I'm going to see that I have this arrow. So this means that my graph is going to go down forever and ever. And so before we go ahead and continue, let's take a moment and let's put in our infinity signs. So on the x-axis to the left is negative infinity. Up top is a positive infinity. To the right is a positive infinity. And then in the bottom is a negative infinity. So I could see that here this arrow is going to go with this infinity. So it's going down forever. So I know that I'm going to go from negative infinity for my range And then I'm going to keep going, and I'm going to look at this arrow here, and I'm going to see that this goes up. So I'm going up forever and ever and ever. So that means that my range is going to be to positive infinity. And that's exactly what range was, how far down and how far up the function reaches on the y-axis. And the range will not always be from negative infinity to infinity. That might not happen every time. Okay, so now let's go into the next box, the x-intercept. That's the real zeros or solutions, the point where the function intersects the x-axis. So this is x, this is the y-axis. If we were to go ahead and just make a line through that x-axis, I'm going to see that my function is crossing the x-axis at 3 spots. Here, here, and here. And so now I have to write the coordinates of those 3 zeros. And so to write that, whenever I write an x-axis, the generic way that I write that is going to be blank, comma, 0. And so I could go ahead and just read off these values. I'm going to start from the left and work to the right. So from the left, this looks like it will be negative 3, comma, 0. This second 0 right here will be negative 1, comma, 0. And then this final 0 here will be 2. So 2, comma, 0. So notice how I had 3 spaces, or 3 points, 3 solutions, and so I will not always have 1. The y-intercept is the point where the function intersects the y-axis. So now I'm just looking at the vertical axis here. And so here I'm going to go ahead and see it crosses the graph at this point. And generically, when I write a y-intercept, that's going to be 0, comma, blank. And I'm just going to read off that point that it crosses. So this is 1, 2, 3, so negative 3. So it's going to be 0, comma, negative 3. Now, with the y-intercept, I should always have 1 y-intercept. With the x-intercept, it's going to be very common for me to have more than 1. Okay, right end behavior, left end behavior. So we learned this yesterday. And so let's just review. I want to review what rise and fall looks like real fast. So rise, that would be like if my graph was going up, and then fall would be like if my graph was going down. Okay, so now it says, is the right side of the function rising or falling? So I'm going to actually take 1 second, and I'm going to erase some of this. I feel like it gets a little messy. I'm going to keep those points in there. So we're looking at the right side. And so the right side is over here. So I want to look. Is the graph, is that arrow pointing up? Is that arrow facing down? And I'm going to see that the arrow is pointing up. So that would go ahead and be that it is rising. Now I'm going to look at the left end behavior. So with the left end behavior, I'm looking at the left side. And I want to look, is my graph going up? Is that arrow pointing up towards the sky, or is that arrow pointing down? And we're going to see that the arrow is pointing down, so that's going to mean that it's falling. So for that, we just look at the graph and look at what the arrows are doing. I'm going to erase this again. So increasing, decreasing. So increasing, the values of x for which the function is rising from left to right. You might have heard it going uphill. I like to think if it's increasing from left to right, like reading a book, where it is going uphill, like if I were going uphill, the incline of a roller coaster, and then decreasing is the values of x for which the function is falling from left to right. So I think like that's the fun part of the roller coaster where you're going down and you're like, whee! So it's going downhill. So we have to look for that in the graph. Now, what I need you to realize is that we might have more than one interval here for these, and this is where we're going to use that point A and B. And we always, always, always write these intervals using, so let's just make a note of this. We're going to write the interval using the x values. So let's go ahead, and what we're going to do is, I'm going to see if I can do this. I'm going to take the gray, and I'm just going to cross out all of the y values because I don't need them. I'm not looking at them. I'm only looking at x. In fact, let's go ahead and let me do that one more time. Let's do that with the points as well because I don't really need the y values of the points. I only am looking at x. So let's start with increasing, where we're going uphill. When I read from left to right, I'm climbing up the hill. It's where I'm rising. And so I would go ahead and I'm going to highlight that. So that one piece would be here. So here's one interval for that. And then I'm going to look at the rest. So I'm going to see that from A to B, no, that's not going uphill, that's not rising. But from B on would be. So I have these two interval pieces. And so let's go ahead and let's write this. And so we're going to read what the interval would be. So I'm going to see I'm going from negative infinity because I'm looking at the x values all the way until this point A. That was where I highlighted, that was with what was yellow. And so that would be this negative 2.12. So I'm going from negative infinity to negative 2.12. But I have another interval there. And so I'm skipping that piece from A to B. So whenever I skipped a piece from in my graph or in my interval, I would put a U there. Like no man's land. I'm skipping that piece. I don't care about it. And then I'm going to go ahead and I'm going to pick back up from this B, and I'm going to keep going to the right, and that's where that infinity is. So from, I don't know what it was, 0.79 to infinity. And now we're going to look for decreasing. Decreasing is the piece that we didn't highlight from A to B. So that's where it's going downhill, right? I'm going down the roller coaster. And so I'm going to read that interval from the x-coordinate of the A value to the x-coordinate of the B value. So it's going to be from negative 2.12 to 0.79. So here are our characteristics of polynomials. Take a minute, pause the video, read through what we filled this in this chart with, and make sure that you understand where it's coming from. Okay, so let's flip over and let's try some examples. So looking at example 1, it says determine the characteristics of each polynomial function. So we're just going to go through and try to identify this information. If you are confused at all, that first page, that first problem, that is a good place for you to reference. So here we go, let's do it. The domain. So the domain is all possible x values. Before we even get started, let's add in those infinities. So we're going from negative infinity, 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 negative infinity. So I'm scanning from the x values on the left to the x values on the right. I'm going to see that I have arrows. So my domain is going to be from negative infinity to infinity, and I told you that's going to happen every time. Okay, my range now. So my range, I'm looking for a lowest point, a lowest y value to a highest y value. So I'm going to see that here, A, this point A, this is the lowest part of my graph, and then I want to go ahead and find the highest point. And so I would see that I'm going to keep going up. And this arrow tells me that this graph is going to continue to go up in that y direction. So I'm going to use the y, the y values. So this range, the range is the only time we're using y. We're also going to use a bracket. And so we're going to go ahead and we're going to use the y value of the y coordinate of point A. So that was negative 3.24, and then we said that we don't know what our highest y value is because I have those two arrows, so it's going to infinity parenthesis. I'm going to erase some of this. The x-intercept is where it's going to cross the x-axis, and I could just read those values off. The order doesn't matter as long as we want to write them as points. So I'm going to start from left and work to the right. So this point would be 1, 2, 3, 4. So this would be negative 4, comma 0. The second one would be negative 2, comma 0. Third one is 0, comma 0. And the fourth one is 1, comma 0. So now when I look for the next piece, that's going to be the y-intercept. So the y-intercept is where it's going to cross the y-axis. So I'm going to highlight that. And I'm going to see that my graph, my function is crossing right here at this point, the y-intercept, and that's going to be 0, 0. My next piece is going to be my increasing decreasing, and so my increasing is like where it's going uphill, where it's going to rise from left to right, like reading a book. So I like to draw a little arrow by these so that I need my function to look like this. And so I'm going to see that that will happen where it's going uphill from left to right is going to be from A to B. And then I also have a second piece from C on. And so let's go ahead and let's write that value. Now remember, when we're using increasing, decreasing, we are only going to look at the x value. So in fact, I'm just going to cross out the y-axis as well as these y values, because I don't need them. I'm not writing that. I write the interval in terms of x. And so let's go ahead and let's write that. So I'm reading from A. So A was negative 3.25. That was the x value, to B. So B was negative 1.07. And I am just reading this from the points that I was given. So I could kind of guesstimate that, but I'm giving you those values, and you'll be given them every single time. So we're increasing from negative 3.25 to negative 1.07. And then we're going to go ahead and see from B to C. That's not highlighted because that is not increasing. That's not rising from left to right. So then I'm going to put that union. Then I'm going to go ahead and I'm going to pick back up from the C. So C was 0.57. And I'm going to keep going, and I'm going to keep going to the right, and that's going to be a positive infinity. So it's going to be 0.57, and then this arrow is going to tell me that it's going to infinity. So decreasing is where it's going downhill, where it's falling from left to right. And so let's go ahead, let's highlight that. So we're going to see that where it's falling from left to right, you're going down the roller coaster, would be from negative infinity to this A, and then from B to C. And I do think it's helpful for you to go ahead and use highlighters to highlight the increasing and decreasing pieces. I know that we did this in class. I think it's just easier for you guys to see what you're working with. So now that we've highlighted these blue pieces, we need to go ahead and we need to write the interval for them. So we're going to see that this over here to the left, this part of the graph, this is negative infinity because I'm only looking at x values. So I'm looking over here. So I'm going from negative infinity to this point A. So to negative 3.25 parentheses. And then I'm going to go ahead and I'm going to see that A to B, I've already accounted for that. I don't know why it's appeared. I've accounted from negative 3.25 to negative 1.07. That was in the increasing piece, so I'm skipping that. And I'm going to go ahead and put a U there. Then I'm going to go ahead and I'm going to see, I need to figure out from B to C what to do. So that would be the x value for that is negative 1.07. And then keep going to C, and C is 0.57. So then finally we have left end behavior and right end behavior. So my left end behavior, I'm looking, is my graph the right side of the function rising or falling? And I'm going to see that it would be rising. It's going up. And then my right end behavior over here, that's also rising. And that would make sense. Here's a check for you. If you're given the function and that highest degree is 4 to the 4th power or an even number, remember that the end behaviors have to match. So if one side is rising, the other side would have to be rising. Okay, let's do one more example. So now here looking at number 2, we're going to go ahead and see that we have a polynomial graph. We're given a function. The domain for this will be the domain that it will be every single time. It's going to go from negative infinity to infinity. Let's go ahead, let's throw in some infinities just to kind of give ourselves a reminder of what's going on. Then the range. So now what we're going to do is we are looking for the lowest point to the highest point. So, and I'm looking in terms of the y values when I do this. So if I were to look at the lowest point of the graph down here, I'm going to see that I have arrows there. So I can't name that lowest value, it's going to go forever, never, and ever, and I can never give that highest value. So that would be negative infinity. Then I'm going to go ahead and I'm going to scan up to see where the highest point is. It's not going to be C, it's going to actually be A. So A is really the highest point, and I'm going to write this with the Y value of A, that 4.81. So comma 4.81. And I'm going to put a bracket there. Okay, I'm going to take a minute, I'm going to clear out my graph a little bit. And so now let's go ahead and let's just go through all of these pieces. The x-intercept, where it crosses the x-axis. So here's the x-axis, and I'm just going to write this like a point. And so remember, when I do that, it's going to be blank, comma, 0, and I'm just going to read from left to right. Order doesn't matter as long as you get them all. So this looks like it's going to be 1, 2, 3, 4. So negative 4, comma, 0 for this one. This would be negative 1, comma, 0. The third one could be 1, comma, 0. And then the fourth one is 1, 2, 3. 3, comma, 0. The y-intercept is where it's crossing the y-axis, so I've highlighted that blue. And I'm going to see that that would be right here at B, actually. And so this is going to be one of the few times that you can't read the value. It's not at a nice point, but I gave you that value as one of your points. So it's going to be 0, comma, negative 1.20. Okay, I'm going to take a minute. I'm going to clear off the graph. Okay, so now we're talking about increasing, decreasing, right? So remember, increasing, decreasing, we don't care about those y values anymore. So I'm going to cross out, and I'm going to cross them all out on here too. So we're looking where it's going uphill, where it's rising from left to right. So it's going like that. And so I would see that I'm going to have a few places that happened. So I'm going to see that that's going to happen from this negative infinity piece to A. And then it's from A to B, that's going downhill. But from also B to C, it's going uphill. And so now we got to go ahead and we got to write the interval of those yellow highlighted pieces. So I'm going from this arrow, which is going to be a negative infinity, to that x value of point A, and that's negative 2.94. I'm going to be using parentheses here for all of this. Then from A to B, that's not highlighted, so I'm skipping that piece because that's not increasing, so I put a union there, a U. And then I'm going to go ahead and see that I need to write the interval down from B to C. So B was 0, and then I'm going to keep going to that x value of C, which is 2.23. Okay, so decreasing, where it's going downhill, where it's falling from left to right. And so it's falling from A to B, and then it's falling from C to infinity. So these blue pieces. So let's go ahead and let's write this interval. So I'm going to use the x values for this. Point A, that is negative 2.94 to B, and B was 0. Now I'm going to see I have from B to C, that's yellow, so I'm skipping that interval because that's not decreasing. And then I'm going to go ahead and I'm going to write from C to a positive infinity. And remember, it's a positive infinity because I'm looking at the x-axis. And so it's going to be C is 2.23 to infinity. Okay, the left end behavior, the right end behavior. So the left end behavior is right here. Is it rising, going up, the arrow points up, or is it falling? The arrow is pointing down. It's falling. And then the right end behavior, we're looking over here, and we're going to go ahead and see that that is going to be falling. It's going down. And so if you need to check for that, look at that highest degree. The degree is to the 4th power. It's even. Those end behaviors should be the same. So what I want you to do for this last one, number 3, is I want you to pause this video. I want you to try this out on your own and see if you can get the answer. So pause it, try to answer all of this information about the characteristic of the polynomial and see if you can get it right. Use this as an opportunity to really try to gauge yourself on what are you confused on, what do you understand, do you need to get some extra help on this? So go ahead and do that. Okay, so here are the answers to number 3. So go ahead, check them and check yourself and see how you did and see if you understand how to determine the characteristics of polynomials.